interactive session. If you did, we have 2 more papers in this session. And because we're now already running a little bit late, let's get started right away with Mauricio.
Yeah, okay. Thank you, Lina. So, hello everyone. My name is Mauricio Verano. I'm an assistant professor at the Vrije Universiteit in Amsterdam. And today I'm going to present some work that we did with some colleagues from TU Eindhoven and also from the Open University. So I think most of you or many of you were here before in the workshop, so I think we all are interested or somehow participate in teaching programming either to children or maybe to graduate students. So in this paper, Programming Smart Objects, how young learners' programming skills, attitudes, and perceptions are influenced, we were exploring on how using IoT devices and smart homes can be used maybe to influence or to measure if there is an implication on using this setup to teach programming. So our main motivation here is that, well, we know that for children and for young learners, it's hard to understand programming. Sometimes they struggle with different things. Syntactic knowledge, maybe conceptual knowledge, strategic knowledge. So these are all things that are like, some of them they're just like, okay, I don't know what this is about. This is really hard. And this reinforces this stigma of programming being super hard. So then, of course, one option is we can look into introductory programming environments. And then maybe with this, we can influence how this target group, well, learns programming, and maybe it lowers some of those entry barriers. In this direction, so we have block-based programming environments where it was shown that, okay, children have access to these blocks that maybe it's a little bit less intimidating than just the traditional terminal that we use. So following this, then we thought, okay, if we have these block-based environments, let's try to also take these programming concepts from the screen and let's try to put it in a real setup environment. So, of course, children are used to live in a home, to visit places that are familiar to them. So then we thought, okay, how can we use those type of setups and also visual programming environments to help students to overcome the different obstacles that they face when they are learning to program. So with this, we wanted to reduce this complexity of programming and also to help them, some of them, and this was mentioned also this morning in the talks we had about HEDI, where children sometimes they first, well, need to learn a language, their mother language, but then they need to most likely learn a different language to learn programming. So with these block-based environments, it's easier to have internationalization where we can have the same concepts, well, in different languages, so then we are reducing this barrier. And as it was mentioned this morning, well, with HEDI, which is a textual language, we can also achieve the same goal. So then, in this context, we had this smart home, and then the goal was to teach children programming by letting them program a small light. Basically, they had to program this IoT device to be integrated into the smart home setup. Yes, so this is more or less how the setup was. So we had this smart home, and there we can see the children interacting. So what we were trying to look at here was how to measure first the learning of their basic skills, and also how we can measure if they learn something, if they are capable of applying this learning after following this experiment. So the programming environment that we used for this particular project was BISM. So this was developed by one of my co-authors. And the whole idea of BISM is to develop or to program smart devices, right? So then we have these smart environments where we have robots or we have these small microcontrollers. And then with this language, we can really focus on the different primitives that we need or that we use when we are using any of these hardware devices. So BISM is implemented using Blockly, so famous library for implementing block-based languages. And then with this, we let students to play around with the tool and to program the different environments. So this is how BISM looked like. So we have 4 main components. So it's a traditional block-based environment. Here we have the palette. We have here the block editor. And then on the top right corner, we have the code syntax. So if they wanted to look at the textual syntax of the language, they can also look at the code syntax. And then finally, we have some output. The output could be the real output from the hardware device, or it can also be something as a consequence of the project. And then we have this 2D view of the smart home. So on the bottom right corner of the screen, we have the 2D representation of the smart home where the students were programming the smart device. So then we look at the goal of this study. So the goal of this study was mainly to show what's the potential of using these block-based environments and how we can take these technologies together with a real setup environment where we have a home, which is a familiar place for students. So we want to see how we can merge these two together to make it like more, first more engaging and to see if that has any impact in their maybe feeling towards programming. So this is a brief summary of our study design and the data collection strategy. So this was designed as a 2-day workshop in which we had 28 participants. So they were all 8th graders in Germany. And then we had these two groups where we can clearly see that we had 22 boys and 6 girls. And with this, we already observed that it was hard for us to collect a more balanced sample. So this is super unbalanced. And then we also noticed that in the workshop, because we made first an entry questionnaire, we noticed that some of them, they already have some programming experience. So all of them had some programming experience. But the girls particularly, they had experience on programming microcontrollers. So this was interesting, and that's why also the girls, we asked them to do some particular tasks with microcontrollers. Then, as I mentioned before, so we had 3 different types of questionnaires. So we had questionnaires at the beginning of the session, in the middle of the session, and after the whole workshop to see if there was any change in the skills or in the behavior towards programming. But also, we conducted some tests at the beginning in terms of computational thinking. So we conducted one test before the workshop, like just at the beginning of the workshop, and one after the workshop about more computational thinking aspects. So, for instance, this is an example of the questions that we had. So we had, for instance, do you think you are good at programming? This is mostly to see what was their attitude towards programming. Do you think programming is fun? So they had to classify this. And then in the pre-questionnaire, we have like, have you ever worked with a microcontroller? Have you ever worked with a block-based programming environment? So that we have a better understanding of the population that we were studying at that moment. So with the programming questions, so we had this pre-computational thinking test and then this post-computational thinking test. So we wanted to know their prior programming experience, right? So we wanted to know whether they already had some notions of programming, for instance, some basic concepts, if they were understandable of what's a variable, how to use a variable, control flow statements, if they knew how to use if, conditionals, and this type of things. And finally, to also see whether they know how to use loops or not. Then the procedure that we followed during the workshop was it had a duration of 6 hours with 90 minutes break each day. So the group work, so students were working in groups. So we made these groups based also on the results that we got in the pre-questionnaire so that we can team them up with more or less similar level. All questionnaires and all programming questions were answered completely individual. And the way that we followed the workshop was first, one of the members was explaining them about the system itself. So what was the system, how to use BESM, and how to express the different things that they are capable to do with the system. And then we also gave them some technical documentation so that students could also just check maybe what's allowed, what's not allowed in the system, if it was not intuitive for them. So here we have a small representation of the 2 days. So the first day, well, we start here, and then the first day we started with the answer to answer the prep questionnaire and the prep questionnaire. Then we performed some programming tasks. So these programming tasks were concretely these two that we have on the top of the screen. So to program a mini board and then to control an OLED display. So that was the main task in the first day. And just immediately after that, well, we asked them, okay, well, please answer this questionnaire again to see if their perception has changed or not compared to what they said before performing this task. And then at the end of the day, we try to just get them familiarized now with the smart home setup. In the second day, we can try to integrate the IoT device. So in the second day, we followed the programming instruction to explain them like how the system works, how to connect the different items into the smart home. And then we performed these other tasks where we program the mini board, and then we try to connect the device to the smart home server and to collect the data. So the second one was really like more the integration part, where we integrate the smart device or the smart light that they were developing. So based on our results, so this is just a brief summary of our results. So we noticed that in the computational thinking tests, we can see that there was a small increase in their acquisition of programming skills. So after the whole training, we noticed that there is some change in their perception towards programming in terms of comparing to the entry test. Then we have these results that are mostly focused in terms of confidence, interest, enjoyment, and perception. So from here, we notice that their confidence in most of the cases increased. So we noticed that there was clearly a change in terms of confidence. In terms of interest, that was interesting because first, it was already quite high at the beginning, so they had clear interest in programming, but after the workshop, we noticed that this number slightly changed. So then that triggers questions maybe like, okay, that perception changed just because they experienced something different in the workshop, or there was something that really slightly changed their perception. The same happened with the enjoyment. So again, there was a small decrease, but the enjoyment was already quite high. So still, this is interesting to explore. Yes. So then in terms of limitations and future work, so it was hard first to recruit the participants, and unfortunately we noticed and we are aware that there is like a clear gender disparity because we had only 6 girls and 22 boys. So that clearly influences also the data we have. So that's one of the limitations of the work, and we would like to do this experiment, but having a more balanced sample where we take this into consideration. Also, as I mentioned before, this was a workshop that was conducted in Germany, so all the participants were German students, which again is good to understand a particular population, but it would be interesting how we can have a similar experiment, but with people from different backgrounds, different nationalities, and see how this might influence this. The sample size was also relatively small, so we only had 26 participants. Also, as you noticed, the programming questions, they were also quite limited because, again, we had this 2-day workshop, which in theory sounds like a lot, but in practice, there is not a lot of time where you can really explore something in detail. So this kind of opened up many different paths and questions that maybe we would like to focus in the future. So for instance, for those of you that joined the session this morning, for instance, focusing on the roles of variables, that would be interesting to see whether these type of studies can focus, okay, let's see how this affects maybe their perception of programming. And to conclude, so what I presented was how we used a smart home setup to integrate learning programming, basically by integrating an IoT device into a smart home, and how that can maybe influence the skills or the enjoyment of young learners. So we integrated a smart lighting object into a house to motivate young learners, and also to show how the skills and attitudes of students change after experiencing this workshop. And with that, I conclude my talk. Thank you so much.
Thank you for your talk.
Try now.
Yeah, now it's muted. There we go. Yes, thank you for your talk. Any questions?
So thank you for that talk, and I think that using smart objects is a fairly good way to motivate students, so kudos on that. What I wasn't clear about, and maybe you can clarify for me, you measured that they had acquired programming skills by the end of the 2-day workshop, correct? Could you tell me specifically what programming skills the students walked away with?
That's a good question. Yeah. So, because again, as I mentioned at the beginning, so this is a small example. Where was it? Yes. So this was a small example of the questions that we ask the students. So, for instance, in this concrete example, we have would you like to learn how to program? So we try to use this type of questions to look at it in a more like a global way, not really in something particular. So that's something that we will also like to explore in the future, to really focus on, okay, let's say that the goal of this workshop is that they understand how to define variables, or how to use variables, or how to use for loops. And then we can specifically measure and tailor this type of questionnaires and questions towards seeing their understanding on a particular topic. So in this case, it was more focused on how to use this smart device and how to integrate it in a more abstract way rather than going into concrete details on programming specifics.
Okay, so future work, correct?
Yeah.
It's just a feedback. One of your slides said that they acquired programming skills. And so that was what threw me off.
Okay, yeah, no, thank you so much, yeah.
Yeah, thanks for the talk. I was wondering what sort of manipulation were the students asked to do with the smart device?
So basically what they had to do, I don't know if it was here in one of the slides. Let me see if I add it here. So basically they had to, no, it's not here. Yeah, this is moving too fast. Okay. Yeah, so they had to take this IoT device, basically this microcontroller, and the idea was that they were able to just light it on and to change the colors of the lights, depending on where they were moving inside the house. So that was the whole idea, that they see that they programmed something and they can really see the effect of what they programmed in real life.
Cool. Thank you.
Yeah, thank you.
Let's thank the speaker once more.
Thank you.